No, thanks. I'm happy. I love coming back to Velocity. I was just talking to Tammy Everett. I don't know if Tammy's here or not recently, but she was talking about how every time you go back to Velocity, it feels a little bit like going back to summer camp because you get like that kind of atmosphere, like all the the people and that are really excited and passionate about performance. So I guess it's kind of a geeky summer camp, but whatever. It's cool. Like it is. It's got that sort of community atmosphere around it, which is awesome. And New York is great because New York is so incredibly different in every way, shape, or form from where I live. New York has, like 8.5 million people or so in the city, something like that. And I live in a town of 1,300. I tell people all the time that we have more animals there than we have people, and nobody ever believes me, so I've decided I've got to start providing photographic evidence. So this is a photo from one of my neighbor's backyards. Like, we really do have more animals than we have humans. But it's a great place. It's beautiful. It's gorgeous. There's a thick forest. It's the largest concentration of fresh water in the U.S. is in the county that we live in. It's a really beautiful area with lots of lakes and ponds and things like that. And there's great trails that wind through that, because in the winter, those trails have to be snowmobile trails, because that's the only way we get people to come up there when there's that much snow. So they maintain these very well, and they kind of wind through the woods, and they're very scenic, and they're awesome for biking or walking. When we used to live on them, it was great for taking our kids out for naps, because you'd put them in the stroller and push them down the trail, and they'd just sleep the whole time. So what used to happen, we had two at the time, and I would take my oldest, she would take her little baby doll stroller and put like a baby doll in it and push that. And I would put her baby sister in a stroller, and we would head out, and we'd walk as far as we could before her sister started to wake up. That was kind of the process. Now, even in this sort of peaceful backdrop of this like scenic trail, I was still driven. I guess the performance is still like I had to keep the performance up and the pace up, because there was a part of the path in particular that kind of looked out over a beautiful little lake, and it was very far from any sort of houses or roads. It was just very quiet, and there'd often be like deer drinking from the lake, and so you could just stop and just look out, and it was just gorgeous. But it was a ways out, so we only got there if we went directly from the house to that spot. We just kind of kept a good pace and kept going directly from point A to point B. Now, those of you who have little kids or who have ever been around little kids understand that you never really go directly from point A to point B with little kids, right? For those of you who don't, the best comparison I thought is, so if there's apparently a DevOps after dark party, right? So let's imagine that to get to this party tonight and to be allowed in, you actually had to go from here to whatever the venue is, and you had to corral like 12 squirrels with you along the way, and they had to get there successfully as well. That's what it's kind of like walking with little kids. My daughter would stop and look at everything. Acorns, pine cones, leaves, rocks, ants, grass, you name it. She would look at these things and her eyes would go big with excitement, because to her, these were awesome. Like, she would pick these things up and she would take them home and she would call them her treasures. In fact, all of my kids have done this. They collect these things and call them treasures and store them in little boxes. And when they're very generous, they may give you one, which is always a really interesting exchange to watch, because here, if my daughter comes up to someone and hands them a pine cone, that's a huge commitment. That's like basically wedding ring territory. That's pretty intense. And it's always fun to watch the adults to see how they react, because there's nothing remotely exciting to most of us about pine cones. And if somebody in this room is really passionate about pine cones, I'm sorry for offending. But there's nothing particularly exciting to us about that, right? It's kind of boring and mundane, and we don't give it a second thought. But my kids have an entirely different view of the world, and it completely alters the way that they view the things around them and the way that they interact with them. I try to remember this because I think it's an important lesson for us working on the web. We have an entirely different view of the web than many of our users, and it completely changes the way that we interact with the web and the way that we view the tools related to the web. Particularly those of us in a room like this. We have high-speed computers. We have multiple devices that we probably switch between depending on what we want to achieve. We typically have high-speed networks. We don't have many costs that stand in the way of us getting online or any religious or political barriers. It's kind of a rosy view of getting online and accessing the web. And it changes the way that we view the tools related to the web. In a recent discussion, semi-recent discussion on one of those really nuanced, articulated, calm, well-thought-out things that Twitter is so good at promoting, a friend said that Opera Mini is a crappy browser. I'm not going to call him out by name, because he is a friend and he's a heck of a developer. So I would never do Dave like that. But and I also don't want to call him out because this actually isn't his own opinion. This is something I hear a lot from some really, really intelligent people over the time is proxy browsers in general are crappy browsers. They don't do things that a typical modern browser does. They behave in really illogical ways that we don't understand. And quite frankly, we don't need them, so we don't use them on a day-to-day basis, so we don't see what they're worth. So we tend to undervalue them, and we dismiss them as sort of antiques and relics of a troublesome web gone by. But if we remember that our view of the web isn't the same as everybody else's, we start to get a very different picture. There was a really fascinating study about barriers to online access, like what stands in the way of getting people online. And they broke it down into 4 basic categories. There's user capability. So this is one potential barrier is literacy, like digital literacy or language literacy. This could potentially stand in the way of somebody getting online. There's incentives. So maybe there's a lack of awareness in the area or use cases. Lack of localized content, or there's some cultural or social issues here. So in a lot of countries, for example, the internet, getting online, it's a highly restricted environment, right? It's not open the way that we view it. Places like Iran, where a grand ayatollah has come out and stated that high-speed connections like 3G are against human and moral standards. In markets like this, what often happens is they will throttle the internet because it's a way of sort of controlling the flow of information by basically shutting it down. So incentive and the freedom to access the web is another potential barrier. There's affordability, low income or purchasing power in a market, cost of ownership of the device, or cost of the data plan, which is an interesting one because we don't often think about that from a US or North American perspective. But if you look at what we've done over time, we were talking to Jeff Veen actually on the Path to Performance podcast, and Jeff has been kind of everywhere. Adobe, Google, he, I think, led the Wired thing, which was like the first major site with CSS. He's been there for a long time. And he said, as you look at what's happened to the web over time, as the bandwidth grows and as the processing power goes up and the browsers get better, we just keep finding new ways to fill it all up again. We just keep using more and more as we're given it. The average site, according to the HTTP archive, the average of the top 1,000 sites, is over 2 megs now. That's a 45% increase in the last 2 years. 45% is a lot of percent points. And there's a real cost that's associated with this. I built a site that uses web page test and makes use of some data that was provided by a couple different places that did some studies in terms of the cost of data plans around the globe based on what is a typical data plan. And so you can see how much does it actually cost to load an average page. This is an average one, not a heavy one. And in case the contrast isn't great for some of you, you're looking at, depending on where you are, that's around 20 to 30 to even as much as 70 cents for an average page to be loaded on some of these mobile plans. This isn't an obnoxiously heavy page. This is an average one. As a percentage of how much people earn on a daily basis, that can be as high as 3 to 8% of their daily income to view one single page on one of their mobile plans. I've seen sites run through this where that percentage can be as high as 80 to 90% of their daily income to view that one particular page. We keep filling it up. So infrastructure. Infrastructure is the 4th potential barrier. This is the lack of coverage or access. Maybe it's a lack of adjacent infrastructure like electricity. It could be underdeveloped network architecture or limited spectrum. So related to infrastructure, if you look at some connectivity data from Akamai, you can see that the US has a dramatically different perspective on what average connectivity is than many of these markets that we're talking about. As much as 9 to 10 times the bandwidth as a place like Pakistan or Iran has. Again, the Pew Internet Report had some beautiful graphics and some really good data. It's actually a fantastic report. I highly recommend you check it out, where they looked at mobile subscriptions by region, by technology. So each of these bars represents 100%. And they break it out by what type of technology is used to connect. So you can see that in North America, LTE is 40%. However, 2G dominates many of the other markets. Now, a more interesting view of this is Patty Tolan from the Filament Group decided, well, what happens if we take these bars and we scale them based on how many people actually use phones in those areas? So, for example, Asia Pacific has a much larger amount of mobile subscriptions than we do in North America. So what does it look like if you account for that in the scale? And this is what happens. you end up getting a dramatically different picture, and 2G suddenly rises right to the top, and you see just how insignificant North American traffic is on a mobile perspective. We tend to have this lens that we view things through, right? We're really actually the minority when you're looking at it from a global scale. So this study took these four things, the affordability, the user capabilities, the incentive, and the infrastructure, and they graded all of these different countries. And what they found was that the United States has by far the lowest barrier to access out of anybody in the world. I think the total composite score was like 93 is what we got rated. And Germany and a few other European countries were right behind that. But this is a sampling of them, and you can see how dramatically different their scores are in these different areas. It's much, much harder in other areas of the globe to get online. We have a very, very rosy picture of the web, and that's a problem. Because if you look at this is a map showing internet saturation for different countries around the globe. The darker shades mean that we've basically hit saturation in those areas. These are the areas where 80, 90% of the people are already online. We're not going to get a lot of growth from those areas. The growth is going to be coming from places like Asia, India, Africa, these lighter shaded areas where we have the room for people to come online. And we're actually starting to see this already. In Q1 of 2015, India, APAC, Africa, they contributed 26, and 21 million additional mobile subscribers, and we contributed 6 million. So we're becoming a little bit more irrelevant, actually, as time goes on. And it's going to continue that way. Over the next 6 years, we're going to have an additional 3.5 billion smartphone subscriptions, and North America is going to contribute maybe 120 million of that. Really tiny, minuscule amounts. Our view of the web is not only rosy, but it's the minority. What we view as the web, our internet, it is not the internet of our users around the globe. And that's a problem because that frames the way that we build our sites right now. So what are we doing when we're building things? We're doing things like this. We're re-implementing the entire DOM inside of Canvas so that we can get beautiful, silky smooth animations, which admittedly are very, very nice. But anybody who needs to rely on a proxy browser to get access to a site gets this experience instead. I suppose it's not going to be very janky. It's going to be a particularly smooth scroll. There's not much going on there. That's one upside. When we make decisions to build our sites with tools like a lot of the client-side MVCs that are really, really popular, and we don't back that up with any sort of server-side rendering. And so what happens is, again, those proxy browser people are completely left out of these experiences. And then we kind of demean them. We don't even give them the recognize that it's an important thing to address, because then when somebody suggests, well, maybe we should look at fixing this some way, what happens, the response is that, well, it's probably not even possible or even worth doing. We completely dismiss that use case. I firmly believe that the web's power is ubiquity. It's its reach. That's what the web brings that native cannot. That's why you work on the web. The web is so awesome because you can reach millions of people and anywhere around the world. But when we make decisions and trade-offs like that, we start to take away some of that power every time we do this. It's kind of like the analogy of you have the paper and one tear doesn't do much, but you keep tearing in all these little tears and eventually the paper is completely in shreds, right? That's what we do to the ubiquity of the web with every little trade-off that we make. Now, I gave this a hard time, but to be fair, it's also kind of cool, right? I mean, who would have imagined being able to do something like this 4 years ago on a mobile device, right? This is pretty awesome that we can have these sorts of animations and movements. Browsers are innovating at a rapid rate, and we're capable of doing more things on the web than we've ever been capable before of doing, imagination pushing things. It's amazing what we can pull off on the web. But that creates a friction and a tension. On the one hand, we have the potential of the web, which is pushing at the limits of our imagination. But the reality is lagging a little bit behind. It's something slightly different. Proxy browsers exist to bridge that gap between the reality and what our imagination is pushing forward. And they are widely used. They are not a small percentage of users. So UC Browser has claimed that they have 100 million daily active users. They have 42% market share in India. Depending on who you look at, they have 34 or 35% market share in China. Opera Mini, which is sort of the granddaddy of the proxy browsers, right? As of January, had 258 million active users and had transcoded 168 billion pages. It's a lot of pages being run through Opera Mini. Puffin's a little bit more of a newcomer and not quite as big a player as the others, but it's still one of the top 5 tablet browsers in about 40 countries. And we'll talk about them in a little bit because they do some pretty interesting things. Sencha Mobile provided some data about proxy browser distribution by country, which I kind of used to figure out what proxy browsers I wanted to focus most heavily on when doing the testing. And it's interesting just to see a little bit of where, which markets get which proxy browser usage. So you can see that Chrome's data compression stuff, Flywheel, is extremely popular in North America, South America, and Oceania. Meanwhile, you have Opera Mini sort of dominating inside of Africa and Asia and Europe as a whole. Silk is pretty minor, and honestly, I'm not even sure if Silk is still doing proxy stuff. Unfortunately, the Amazon people are a little tight-lipped on that, which I totally get, but it means it's very hard to get information. Yeah, as far as I can tell, I can't ever trigger any proxy behavior there anymore. But as you start to dig into these things, so you start to dig into these proxy browsers and start to try and categorize them and figure out what they're doing and what they're attempting to accomplish. I ended up putting them in sort of a conservative bucket and an aggressive bucket. On the conservative side of things, you have things like Chrome's data compression powered by Flywheel. You have UC with their Cloud Boost on, and you have Opera Turbo. On the aggressive side of things, you have things like Nokia's Expressor OV browser, which is kind of going the way of the dodo bird. You have Puffin, you have UC Mini, and you have Opera Mini. And based on how conservative or aggressive, they completely change the way that they interact with your pages and what they're doing to them. Before we get into that, it's important that we kind of understand just really at a high level, how does a typical browser behave and render a page? So this might be review for some of you, but we're going to keep it high level, so it's going to be quick. Basically what happens, you get a phone and you decide you need to go and visit this site, right? It has to go out and it has to connect to the web server. And then it has to get the resources for that page, and it's passing those resources back down every time a new request is made. While this is going on, partly, what the browser is doing is the browser is looking for the HTML and the CSS and the JavaScript, because the browser needs to construct a document object model, and the browser needs to construct a CSS object module. So they have to have a model of all the elements inside of the page, as well as all the potential CSS selectors. It pairs those two things together to create what does it actually need to render, to create the render tree. Then it starts to lay things out. Consider this sort of like putting these things as like boxes and figuring out where the boxes are going to go on the page. And then finally painting it. Now that's almost embarrassingly high level, and there's difference in the terminology that people are using from browser to browser, but this is good enough for our perspective. If you look at these things, the stuff that you see here on the left, which is slightly cut off, I see, the stuff that you see on the left is the network constrained, right? So how quickly this stuff happens, or what this impacts, has to do with things like bandwidth and latency and cost of data. That's where these things come into play. The stuff that you see on the right, all the stuff that the browser is doing, the primary constraints in terms of performance are the actual device. So things like memory and CPU, and what the browser is capable of doing. Proxy browsers, conservative and aggressive proxy browsers, focus on one or both of those sides of things, either the network constraints, the device constraints, or both. From a more technical perspective, probably a more accurate representation of how these two categories break out, you have the browsers with proxy services. Almost through that. Browsers with proxy services. So these are browsers, they're full actual browsers, but they can hook into an actual service to do some of this stuff for you. And then there's the remote browsers, which is a term that I completely made up, but I think that it kind of works for reasons we'll see in a little bit. So the browsers with proxy services. So this is, again, Opera Turbo, Yandex, which is basically using Opera Turbo with some very slight alterations, Chrome, and UC Browser's Cloud Boost. They change the model only slightly. So what happens here is when the device goes out to establish a connection to the server, it first actually gets routed through the cloud servers, so Google servers or UCs or whatever that happens to be. Those intermediary servers pass the connection on to the end, to the web server. They're actually making the requests on your behalf. And they come back through and they get passed back to the device. And it continues to do this for any request that's going to get routed through these servers. At first glance, this feels a little inefficient, right? Because you're making a couple different connections here every time. It's important to note that they do have high control over this particular side of the network. So this can be a high bandwidth, low latency environment. Still, occasionally what happens is that if you are in a high network environment and it's using this sort of architecture, you actually will get a slower loading page because it is adding that overhead and you're not getting the gain from that perspective. You may get lower weight though, typically, but you may actually get a slower page depending on your environment. But what this enables them to do is this enables them to use these servers to start to make different optimizations. So for example, they can enable Speedy or H2 on the back end, which has been proven to have 23, 24. It's a good improvement for mobile connections. Pretty significant. And it can enable this for the connections there. It can turn on things like gzip. It can minify the CSS and the JavaScript for you. It can compress and transcode the images. This is actually the biggest gainer for all of these, is the actual image compression or transcoding things to WebP or things like that is the single biggest saver in terms of page weight for these services. Most of the browsers, not all, but most of them provide the user some sort of ability to alter the significance of that compression. So the user can choose that they want it to be extremely highly compressed, in which case it's going to look like crap and your designers are probably going to cry. Or they can turn it off entirely and just have the images not at all presented to them. And again, we talked about the network optimizations there. So they're basically straightforward, and they don't really get in the way of a developer very much, right? There's not too much fallout that we have to worry about. There's a few considerations. So for example, there's a header that gets passed that tells people, it's the remote address header. It tells people the IP address of the device used to connect to a site. Normally, this would broadcast your phone, right? But as soon as you go through those intermediary servers, what happens is the header gets changed to actually broadcast those cloud servers. So if you're looking for this header for your site for geolocation or anything like that, you're going to get a completely different location. To account for this, the proxy browsers, all except for Yandex, which really has no good reason not to do it, but everybody else passes an X-forwarded for header that will tell you the original IP. So now you get two. You get the remote address, which points to the cloud servers, and you still get to find out where the actual user is. There's also additional headers that these proxy browsers pass, a lot of really sort of funky ones, which are fun. There's a content opt header that Opera Turbo will pass, which tells you which version of Turbo has optimized the content, and I guess the existence of that also tells you it has been optimized and run through something. Chrome uses a via header. So the way that they use the via header, you can see the 1.1 is telling you that this particular connection was made over HTTP 1.1, not 2.0. It's the ID for the protocol. And it tells you that it ran through the Chrome compression proxy. Yandex also uses the via header, but they're slightly different in terms of syntax. They've got the full HTTP/1.1 for the protocol, and they're a little bit more specific about where the optimization took place and what processed it. UC Browser, there's always one bad sheep in the bunch. In my opinion, UC Browser is kind of that one. UC Browser is weird. They pass this proprietary user agent string, which actually has a ton of really interesting information in it. It tells you the device, the operating system, the resolution, both logical and virtual, the image mode, are the images turned off or not, is Bluetooth enabled, there's a whole bunch of information, is night mode on, there's a whole bunch of information they shove inside of this. It's kind of like you're aware of like the idea of like client hints or whatever, being able to get information about the browser and stuff that way. It's like a really proprietary, kludgy, messy version of that, I guess, in a way. So you can get at information about all of these things and find out what's happening to your site from them. Again, the fallout's fairly minor. Potential issue one is that minification does remove comments in JavaScript and CSS. Apparently, there are some JavaScript solutions that depend on the comments existing, which I think is a questionable choice. So your solution there is either to don't rely on comments, or to use cache control no transform, which it used to be a lot more Wild West than it is now. Now those browsers all pretty much unanimously will support that and ignore that and not transform the content if you've got that header applied. Potential issue number two is the images could be removed from the page. You want to make sure that you have text fallbacks for any meaningful content images. Yeah, that's a fairly straightforward one. Potential issue number three I've included just because everybody brings it up, but it's like you might get blurry images. You could potentially add cache control no transform and say don't do anything to these images, but that seems like a really terrible idea because the user has specifically said I would like these images compressed. And I don't think that it's really our place to then kind of come in and say, no, you don't get them compressed after all, just because we're a little upset about the pixels. So I caution not to do that. So the fallout's pretty minimal. The data savings are still fairly significant. Opera quotes up to 50. Chrome says up to 50, or approximately 58%. They're a little more precise because there's a nice white paper that walks through all the flywheel optimizations. Highly recommended reading, actually. It's really interesting if you're, it's a white paper, so it's dry, but it's interesting. And UC claims up to 60. In practice, I think UC is a little over-optimistic about their impact. All of these browsers preserve the security as well. If it's HTTPS, they will not they will not intercept the requests in between. They'll bypass the cloud servers and behave in a normal browser way. And they can do that because they are a full browser that just has an optional proxy service that they tap into from time to time. But that does mean that the data savings are a little over-optimistic in everybody's case because once you factor in the fact that people are using a lot of secure sites as well, those data savings slowly start to creep down and down and down. I think Chrome, the 58%, I think actually accounts for that. UC is definitely not accounting for that in 60, and neither is Opera Turbo's 50. In a real user session, that's going to come significantly lower. So those are the first category. The second category, the remote browsers, now these are the fun ones. This is where things get a little bit more interesting and exciting, I guess, if you're a masochist in a way. I like to call these things remote browsers because all of the browsing happens away from the actual device. All the things that we associate with a typical browser doing don't happen on the device you're using. So in this architecture, what happens is you make the request, and again, it's routed through some sort of intermediary servers, just like the browsers with proxy services. That's where it starts to change, because now instead of communicating back every single request and potentially optimizing it, what happens is those cloud servers connect and grab the whole page. They get the whole page on that layer of intermediary servers and then finally pass back something at the end. So what that enables them to do is all of this stuff, all of the rendering, the creation of the DOM tree, the painting, all of this stuff, or the layout, this all happens on these cloud servers. And what they pass back ends up being a snapshot of your website. It's actually, I think last year Ilya threw a little shade at Opera Mini and mentioned something about it not being, that he didn't consider it to be a browser, and it's actually really an accurate representation because in a way it's not. It's a thin client that is serving some sort of proprietary format that just happens to look like a website. Opera's is an OBML, Opera binary markup language. UC's got their own thing. Puffin's got their own thing. But there's some interesting implications of this architecture. The fact that the browser is all on that cloud server has some interesting implications for us as developers. So anytime you're doing something like this, you have a click event or any sort of simple thing like this, the browser might have to do any of these things. It might have to reconsider what the rendering, the layout, the painting, the DOM. And it can't do that on your device. So it has to establish another connection back to the cloud servers. It has to have the cloud servers run and execute that JavaScript and see what the change was and then pass back an updated snapshot. So in the case of Nokia, UC, or Opera Mini, they will do that. They will run the whole thing. They'll pass back an entirely new snapshot. It's not at all related to what you had before, other than that they've executed a little bit further. Opera Mini breaks this down into 2 rules for you to keep in mind, which are really good rules to remember when you're developing on this. Everything requires a user interaction. You can't trigger, as the developer, to go back to the server and update those snapshots. This has to be a user interaction that triggers that sort of behavior. And everything requires a server round trip. It has to go back to the server to get an updated snapshot. And if you remember those 2 things, it actually makes a lot of the other stuff a little easier to at least understand, if not swallow entirely. It also helps to think about it in terms of goals. The goal of these are to limit the data consumed while also limiting the impact on the device. So anything that's going to do not that, like anything that's going to potentially increase the data or potentially make the device do a little bit more work, is probably not going to work in this sort of situation. So for example, the scroll event. As you do the scroll event, you're scrolling down the page. It's constantly firing, right, on all of the elements. If you were doing this inside of one of these proxy browser environments, it would constantly have to be going back to the server and seeing, has anything changed that I need to pass back an updated snapshot for, which would be horribly inefficient. So the scroll event doesn't work. In fact, many events are just out, either for reasons that they're just not practical in that environment, or they simply won't work. There's also limitations on how that JavaScript executes. Opera Mini, which gets a lot of flack because it's the one that we focus on, I think, so we give a lot of our tension and anxiety towards Opera Mini, they're actually the nicest in terms of they document things, which is amazing. Documentation is so very helpful. They point out that like their set timeout, they will terminate a set timeout at about 5 seconds, set interval at about 5 seconds, and an AJAX request at about 5 seconds. So if you've got a set timeout at 6 seconds, don't expect it to run. If your interval is running every second, it's going to run 5 times and be done. There's limits to what it's going to do on the server so that it can make sure that it gets a page out to the user as quick as possible. UC Browser also limits things, but they don't document anything. So I had to actually test and figure out, so what happens in a UC Browser, UC Mini environment. And it's kind of scary. So set timeout actually gets executed immediately. It doesn't matter what you set it for. You can set it for 10 seconds. It's going to be run right away as soon as it comes across in the parser. Set interval gets executed immediately, once. So if you have a interval that's supposed to run every 500 milliseconds or every second, it's going to be executed exactly one time and without the delay or the buffer in there at all. AJAX requests get terminated somewhere between 3 to 4 seconds, which actually provides an interesting loophole. Because if you wanted to, what you could do is you could send off an AJAX request and ensure on the server that it's going to take that full 3 to 4 seconds, and then have your intervals and timeouts running during the time that the AJAX request is firing. So if you wanted to, you could actually force UC to run the timeout a few times by doing like a fake long AJAX request if you really needed to. Puffin is a little interesting. Puffin, I said, was the kind of a newer one and more focused on tablets. What they do on this behavior is they actually don't pass back a full snapshot. So what Puffin will do is Puffin gets the version that it had before and the version that it's now, after it's executed the JavaScript or applied the changes. It compares the two and finds out what's different. And then it passes back only a diff of those changes. So it doesn't pass back the entire snapshot. Their goal is slightly different. They want to limit the data consumed and limit the impact on the device, but they want to provide a nearly equal experience to a typical modern browser. So they do things a little bit differently, and so some of the JavaScript comes back into play. So now you have things like resize and scroll come back in. There are now things that you can use again, but they behave still slightly differently. So for example, scroll only fires once at the end of your scroll, not constantly as you're going through the page, because again, it would be a little too heavy to go back and forth the entire time. You would think that the idea of a diff seemed cool for initially, like in my head, that they would save even more data, but that's not the case because they're actually doing more interactions back and forth. It ends up adding more, so they don't save the same data as these other browsers, but you can use Puffin and still get significant data savings and experience that's a little bit more easy to swallow and digest, perhaps, than some of the other ones. They've all got their own rendering engines. Opera is using Presto. Potentially, eventually, they'll maybe switch to Blink if they can find good reason to do it. Like, again, anything that potentially takes away their ability to reduce the impact on the device or the network, they're not going to do. So they're very careful and deliberate about when they upgrade their rendering engines. Puffin is using Blink in the background. UC has a U2 kernel and a U3 kernel, depending on which mode it's in. And I think one's a WebKit fork and one's a Gecko fork, but they're proprietary and they're very poorly documented. I think if you go to their site in the Chinese version of the site, you can actually find some Chinese written documentation. But as far as anything that I could read, there's not much. And then Nokia uses Gecko, but again, Nokia is kind of being replaced by Opera Mini in just about every single scenario. But again, even though we've got these rendering engines, we can't expect them to behave the same way a rendering engine would happen in a modern browser. Certain things are going to be out. Things like border image and gradients and transitions. Transitions because it is not capable. Things like border image because to do that, they'd basically have to pass back a bitmap. And that would add additional weight, so they don't do those things. They're not going to do the imaging or the radius for that reason. Font face is out, which means that if you are an icon font fan, you're going to be SOL in this particular scenario. They all say you should go with SVG instead. And JavaScript-only APIs like local storage, because again, how can you can't do local storage when it's actually not a browser, it's a thin client app. Which brings us to the disturbing part of the session. So far everything kind of fits within the parameters of what these goals are for these browsers. But this is the part that gets a little weird. So if anybody really, like, the idea of a bug that can't be fixed or that makes no logical sense really irritates you, you might want to leave the room now and then come back in about 5 to 10 minutes. So UC, let's do UC because UC is fun. So UC has no icon fonts, right? So you're like, okay, we're going to use SVG. So you go to see if there's SVG support, and it says, yes, we support SVG. So you include your SVG into the page, and absolutely nothing shows up because it doesn't actually support SVG, even though it claims to. You could try to do the on-error fallback. So if this is a popular technique, include some SVG, on-error, fall back to a ping. So if the SVG doesn't load, fall back to something else. Except there's no on-error event in this environment either. Okay, so at this point, this is a perfect use case for finding out a little bit more about the browser and using some user agent detection. And sure enough, it'll flag something for you. Like, this is the user agent that is passed to the server. We can tell very clearly that we've got UC browser here, and so we can do something different. But you can't do this on the client side because if you go to detect this in JavaScript and you try to get a hold of the user agent, it gives you something entirely different. It says nothing at all about UC web. It's the little gecko user agent string. So you have a couple options at this point. My favorite option for debugging proxy browsers is to cry under my desk with a bottle of wine until all the pain goes away. But if you're not an alcoholic, then your other option would be to do some actual, maybe like server-side user agent, or maybe like a cutting the mustard test like BBC popularized, right? Because again, this should work. Local storage isn't supported inside of these thin client apps. This should work. It should not cut the mustard. We should have a nice simple version that goes out. And in fact, this works great for Gecko or Opera Mini. But UC browser, of course, is like, sure, I can do that. I can do local storage. So you have to get a little bit more specific. And then you have to say, OK, well, we're going to actually try to set and remove and then potentially catch the exception. So now we've got a more robust cut the mustard. Except that now that anybody who's using Safari in private mode for research and stuff is not going to be, they're not going to have a cut the mustard experience either. So then you have to get like really specific and actually check the actual exception. And this is a very dangerous thing because as far as I know, that isn't actually documented. And it has changed already a few times, I think, inside of Safari, what they provide for those. It's a very fun and sort of terrifying experience. Proxy browsers also have these different display modes which have interesting implications. Puffin has the ability to request desktop, which is exactly what it sounds like. They'll request the desktop version of the site. What they do is they set a fixed width of 1024. And they do have sites that don't fit within that 1024 that are not responsive, in which case it's cut off. And the only way to get saved from that is somebody at Puffin has to manually add you to a list that says, we're going to change that viewport to something higher than 1024. So it's not a great process. So the solution's easy. They recommend responsive design, and you're probably going to be good to go. It'll respect all of the viewport stuff and all the media queries you apply. Single column view is a little bit more interesting. This is something that both UC and Opera provide. It kind of heralds from the day where there was nothing happening on mobile optimization, so they had to try and find a way to take your desktop site and fold it into a single column so that it was somewhat viewable for you. But as part of this, they strip out a ton of CSS that I can't find exactly like a documentation from either of them on which CSS it is. But they strip out things, and they'll apply floats in places where they're not supposed to apply it. So you start to get really ugly looking things like that. The solution for Opera Mini is pretty straightforward. If you include a handheld style sheet, you're good to go. It's going to respect the handheld styles, apply those, and it creates a much prettier thing except for the Navicon, which I keep meaning to fix before I present next time so it doesn't embarrass me, but I never do. UC, unfortunately, their behavior is slightly different. So what they do is they actually set the viewport to 1024. They apply all the media queries to create this 1024 vision, and then they collapse it all right back down. So if you're applying responsive design that would look great, they basically blow it up for the desktop and then try to shrink it all back down again. So it's a horrible experience. They shrink it back and shove it back into the actual screen size. So in this case, 360 pixels. And they strip things out for no apparent reason whatsoever, which leaves things like this, where floats are now applying because they've been applied in the media queries, but you don't want them to apply because you didn't want them to apply in the first place. UC doesn't respect the handheld attribute either in this case. So really the only solution is, again, to do some sort of scary cutting the mustard thing, some sort of user agent detection, or just kind of give up on it and understand it's going to be different. The significance and savings for these browsers is huge. We're talking like 90% in many of these cases. That's why people are using these things. And this is a real 90%, by the way. This isn't like inflated because when it comes to secure traffic, they're still doing that. They're still kind of doing the man in the middle here and breaking traffic down at their end. They've got a secure connection from your device to them and from them to the web server. But in between, to do these optimizations, they're changing it up. Which is probably one of the most interesting topics, I think, to discuss around proxy browsers is, should we let them do this? And if not, then how do we fix it? Because people are relying on that behavior right now. And we know we don't want the security to be broken, but at the same time, that 90% data savings can be the difference between somebody getting online or not. So it's not as easy as just killing the proxy browsers. And in fact, we shouldn't expect to be able to kill them. Their user bases are growing. Every single proxy browser I mentioned, except for Nokia, is increasing in terms of user adoption at the moment. In the wave of Internet of Things, it's only going to help improve that. The first browser on a watch, it's a horrible watch, is the Opera Mini browser, right? You could question whether or not a browser needs to be on a watch, but again, one of the first third-party apps for the Android Wear stuff was a Chrome browser as well. People are interested in playing around with it. Cars are even a more questionable area for browsers, perhaps, but again, the first one to get there was Opera Mini. Talking to the folks, UC is all over in terms of TVs. Talking to the folks at Puffin, they very clearly view themselves as extremely well positioned for these sorts of Internet of Things sort of connected devices. They think that that is where they are going to continue to evolve and grow as a base. They're not going away anytime soon. And so we need to pay attention to them because people depend on these things and around the globe to be able to get access. And it's tempting to view them as slightly different than us, but they're really not. In an article about Africa and some of the internet constraints there, they ended the article by saying, we're going to be no different than the rest of the world. We listen to music, we watch movies, we play games online. So when Todd Parker said that, design for everyone always because the crappiest devices on the web have similar specs to the coolest new tech, it's very appropriate and it's very true. You do need to design for everyone always and kind of keep this stuff in mind when we're doing these things. And if I was going to boil down the device into 4 really quick bullet points, it would be build with progressive enhancement, start with a structure of HTML and layer on the CSS and JavaScript with care, so that when it pulls things out on you, it's not going to kill things. Use responsive design, which gets you around a lot of the quirks. No heavy JavaScript frameworks, which is the one where usually people throw something at me when I bring that up, but it's the truth. Like that adds a lot of weight and a lot of overhead to these devices that these browsers are not going to be able to support. And some sort of a cut the mustard check, which I think is going to be an increasingly important check anyway as time goes on and as the rest of the world gets online. But probably the single best advice comes from John Alsop's article, the Tao of Web Design from like 2001. I just told him the other day that I'm going to have to start paying him for how often I've quoted his article. It's fantastic. But he said the journey begins by letting go of control. There are things in the proxy browser environment that we can't control. And these are things that the user has specifically opted into. And so maybe it's not up to us to control their experience in those situations. I think letting go is the best approach. And I think that there are literally billions of potential readers, of potential customers. There are billions of people that are all hoping that we will. Thank you.